Welcome back, guys. Remember this beast? Well, not exactly a beast, but remember this bike. KTM Duke 125 with the dodgy generator. Well, I've got it actually here in the shop now because it needs some other things. It's got some leaky fork seals, and what else does it need? Can't remember off the top of my head. It's here for, clutch cable and a few other bits and pieces. Got a little bit of time on my hands, so I thought I'd just do a bit of waffling about generators. Hope you find it interesting. So this is a new generator. Turns out it's cheaper to buy a genuine KTM one than buy an aftermarket one, which is slightly random. So get this out of the bag without cutting into it, and do a bit of explaining about how these things work. Old news to some of you, I'm sure, but apparently you guys like a waffle, so I'm going to give you one, so to speak. Right, rubbish, go away. Okie dokie. Okay, talk a little bit about the anatomy of these things. I guess to the untrained eye they look a bit complicated, but in essence all this is three pieces of copper wire joined together. That's all it is. Right, I'm going to try really hard not to murder this subject and have the world of internet hate come raining down on me. So the anatomy of a generator, as I said a few minutes ago, it looks complicated, but in essence it's three lengths of wire. Right, so how to explain this? So I've got some trusty cable ties here. So hang on, let's go previous. I need a what's it to mark on this generator? I need a pen. Hold that thought. Right, so I'm going to do my best to try and not to murder this subject too horrifically, and not get too bogged down in detail, because you know how I like to go off on a tangent all the time and waffle on and on and on. But right, let's get down to it. What's going on with this thing? It looks super complicated, all these wires and blah blah blah. Anyway, so essentially it's three lengths of copper wire. So just going back to school, let me use a cable tie as an example. So imagine this is a length of copper wire, right, and imagine this blade is a magnet, right? If I connected my voltmeter up, and I know this is absolute old news to a lot of you, and just fast forward or turn off or something if it isn't, but this might be helpful for some people that have no understanding of what's going on with these things. So, and this is, I'm pretty sure I covered this in my charging system video. If you want to go back and look at that, I probably did a better job of explaining it then. But imagine this is a length of copper wire, right? And I had my voltmeter, my positive and negative of my voltmeter on either end of this piece of wire, and I got a magnet, and I passed the magnet over the wire. Okay, I would induce current flow in this piece of wire. So as hypothetically, or not hypothetically, this is what happens. So as I bring the magnet towards the piece of wire and the magnetic flux is passing through the wire this way, right, we're going to get deep into physics here, and I'm definitely not a physicist of any description, but as a basic understanding of what electricity is, piece of copper, right, a real basic explanation, a piece of copper has lots of free electrons, which means the atoms in the copper have electrons that can move from one atom, from the orbit of one atom to the other. So there's lots of free electrons that will move from atom to atom, so electrons that will travel through the material. So copper is a really good conductor of electricity and heat. Different thing, but same thing. So free electrons in copper move readily through the material. If you had a piece of porcelain or a piece of plastic, the electrons are fixed in place and they're unable to move from one atom to the other. Anyway, so people kind of think that a generator makes electricity. Well, it kind of does and it doesn't. A generator doesn't make electricity any more than a pipe makes water. It's just a sort of a means of setting up a potential difference. That's a bad explanation. So let me carry on with my analogy in this cable tie and this blade. So voltmeter connected to either end of this cable tie, pass a magnet over the wire, and you induce an electric current through this wire. So as the magnetic flux that's coming out of this magnet passes over the wire in this direction, current flows this way. As it goes past center and goes off the other way, the current and the magnetic flux is moving away, current flows in the other way. So as I pass this magnet over the wire, I get current going this way, then this way, this way, then this way, this way, this way, or whichever way it is. But you see what I mean? Current flows in two directions as I move the magnet over the wire. So that will hopefully make a little bit more sense when I explain with this thing. So what have we got here? We've got 3 wires and a load of copper windings. So essentially what we have 3 lengths. Don't get confused by all these windings. There's 3 lengths of copper wire in here. So let me give you an example. I don't know where this will come out. Let's say, for example, this is number 1. So this yellow wire, okay, comes down into the generator here, and then that'll be that wire. It'll be wrapped round and round and round and round and round that. Then it'll miss 2, and it'll be a same piece of wire. So it'll go round and round and round and that, and then it'll pass along. It'll go round and round and round that, and then it'll pass to that one. It'll go round and round and round that one. Then it'll miss that one and that one. Round and round with that one, round and round with that one, round and round with that one. So that's number 1. So that there, is that coming out on camera? I hope so. So if I'm doing a good job of explaining this one wire comes in, goes, let's, for the sake of argument, you can probably see on the back actually how these wires skip a couple of coils. So this one wire goes to, let's just say it's this coil. It could be any of the others. I can't really, you could trace it if you really wanted to, but it comes into this coil, gets wound round and round and round and round that coil a specific number of times, then it jumps over, look, round and round around that one, then the piece of wire continues round and round around that one, continues round around that one, continues to that one, then to that one, to that one, and then, right, hold this in your thought, in your mind, right? Just leave that end of that wire just dangling in midair where it finishes winding around that one, okay? Just hold that in your mind. Now this one, let's say this is got 2 little marks on it. That can be that one, and 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 that one. So same thing. In, all the way around that one loads of times, all the way around that one loads of times, 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 that one, blah, blah, blah. Get the idea. Wire dangling in midair, just imagine it's just flopping around, it's been wound round, it's just dangling out the bottom. And then obviously let's do 1, 2, 3 on there, same thing, 1, 2, 3, 1, 2, 3. Okay, this is massively waffly, isn't it? So put that to one side. Right, so imagine for one moment that these 3 cable ties are the 3 wires we were talking about. Imagine those ends there are the connection block where the yellow wires are, and these are the ends of the wires we've just wound around the laminated core thingy bob, this bit here. So this is especially, anyway, let's not get into that. I will drown in waffle if I go down that road. So what we're going to do with these 3 ends that we've got, we've wound the coil now, we've got 3 ends dangling. Well, you do one or two things with them. You connect them all together like that. Okay, that's called star configuration. Okay, so yellow wire, yellow wire, yellow wire, no ground, it's insulated from ground. Somebody was coming then? No, nobody there. So it's insulated from ground, just got the 3 yellow wires. It's called, what's the word I'm looking for? It's a balanced generator in the, right, let me explain. So you know when I do me testing with me probes, I go on to 2 of the connections at a time. Okay, what I'm doing is, as the magnets are rotating around passing these coils, okay, it's inducing, remember the magnetic field passing over the wire? Well, it's inducing current flow, not just through one of the coils. What am I trying to say? If you took a coil, one of these windings on its own, and passed the flywheel, passed the magnet over it, you would get a given potential difference. You'd get a given voltage, and depending on how much resistance was there, a given amount of current flow. Well, let's not go into that. So if you took one of these coils on its own in isolation and looked at that phase, you would get a, let's just say, for a given RPM of the engine, you would get 20 volts peak to peak. Okay, if you wire them in a star configuration like this, am I murdering this subject yet? Possibly. You're getting the combination of this coil and this coil. When you measure, you're not measuring that one on its own, you're measuring from there to there. Now you're not getting double. It's something like, I can't remember the maths, it's something like 1.7 or something of the combined value of the two coils. Does that make sense? And because current is flowing this way and then 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 this way, you don't get, there's no need for an earth. It's balanced, it's AC, it goes this way and then this way and then, you see what I mean? Does that make sense? I think so. And then the other way of it's the other way you can wire a generator is in delta like that, and then you'll take off the corners for your 3 yellow wires, and that's normally done when you require a higher current demand. I'm not going to get into the science and the maths of it, because I'll just yeah, let's not do that. Anyway, so that's basically what's going on with when you look at a generator like this. Wow, it looks complicated, all those copper wires. It's 3 lengths of copper wire wound around these laminated iron cores, and the reason I say laminated, can you see if it'll focus? See the little lines? Okay, the way this is manufactured, it's like it's been 3D printed or something. It's just loads of slices all laminated together, and it's designed that way because as the magnets pass over these poles, the magnetic flux, what's the word I'm looking for? Penetrates? That's not the word. The magnetic flux, what's the word I'm looking for? Can't think, but you know what I mean. The magnetic flux passes through the laminated core much easier, and the magnetic flux is transmitted to the wire in a more efficient way. Have I made sense, or is that a complete waste of everybody's time watching that? Anyway, so that's what's going on there. I'm going to show you, I just thought when I was doing the initial test on this Duke 125, I was showing you the sort of good sine wave and the rubbish sine wave. It occurred to me after I'd done that measurement that I could have actually shown you the good and bad on the same screen, because it's a 2-channel scope. So I'll probably do that now just before I take this generator off, and then you can, I don't know, it might be interesting to look at anyway. Cool, right, onwards. So what you're going to see on this screen is you're going to see 2 waveforms appear when I start the bike. One is going to be a good, or well, not necessarily good. One is going to be better than the other, and you'll see different amplitudes. And if you know how a 3-phase generator works, you'll understand that they're 120 degrees apart. If I could show all 3, they'd all be 120 degrees apart. So the yellow one, I think it's coming out yellow on the screen, is the good one, and the green one above it is the bad one. I rev the engine, you'll see the amplitude of the yellow one increase slightly. So if you notice there, it's hard because they're bad. I'll show you actually when I put the new generator on. I'll show you what it should look like with 2 good phases. But they're 120 degrees apart, so we've got this one and then this one, and then if there was another one it would be in this gap here. Anyway, don't want to get into that, don't want to go down that rabbit hole. Thought you might find that interesting. I'll show you it with 2 good phases when I put the new generator on. There she is. Now, if I was a betting man, I bet that was a bit fucked. Look at the state of it. It's completely charred. I'd also put strong money on, when they're this burnt, it suggests there's a short on. So if you shorted 2 of these wires together and ran the engine, you'd have a massive, what am I saying? The phases would interfere with each other, effectively like having a short with a battery with a DC supply, generate massive heat. And if I had to put money on it, I'd say the regulator rectifier is probably knackered as well, and it's shorted out the generator. I'll be paying particular attention to the regulator rectifier before I even start this thing up. Anyway, thought I'd share that. That's pretty toasty. Hey guys, so while we're on the subject of magnetic induction, which is the principle of inducing a current flow in a piece of wire by using magnetism, or vice versa, passing current through a wire creates magnetism, which is the same thing but backwards, if you see what I mean. Anyway, this isn't a physics lesson. This little noggin here, crank position sensor or ignition pickup, probably worth a mention while we're under here. So you can see these little lumps here on the flywheel. So there, get that to expose a bit better maybe. As they pass this pickup, this is magnetic in here, and there's basically a laminated iron core in the center, which is magnetized with a coil of wire around it. As these lumps pass the tip of this sensor, it's hard to get the camera in there and show you, the magnetic flux is attracted to each of these raised metal pieces. As it passes the tip of the magnet, the magnetic flux flows into this metal piece. As the magnetic flux moves, get that in focus, as the magnetic flux moves, it cuts through the wires that are wound around the core of this, and it creates a little sine wave, and that's how your ECU of for your engine, or that's how the control system for the engine knows at what position the engine is in. There's usually, with a modern bike, there's normally more than one. There's normally a cam position sensor as well, and sometimes multiple crank position sensors. But in this bike, there's just one crank position sensor. And what it does is it counts these teeth, and as it goes along, get this one in shot here. So I don't know whether we can see down here. Use my finger. See, there's some missing there. So they're all spaced evenly, and then there's a gap, and that it works out from where that gap is. And counting all these teeth, it can work out exactly to within a degree, I would imagine, or two, exactly where the crank is, so it can fire the ignition coil and various other things. Anyway, I'm waffling, aren't I? But I pointing that out to you because when this is back together, I'll get that waveform from the crank position sensor up on the scope, and we can have a quick goosey gander at that. Anyway, carry on cleaning this and put it together. So, will she or won't she charge? Let's find out. Yeah, baby. Right, let's look at the waveforms and also look at that ignition pickup. Interesting waveform there. Anyway, so this is the new generator ticking over. I haven't got the regulator rectifier connected to it. I don't know what's going on here with this. This is weird. But anyway, you can see how I mean, this is just ticking over now. It's, nearly 40 volts peak to peak. If I rev the throttle, it just overranges massively. So when I said I was looking at a phase that I thought was, well, I considered it the good phase and said, I think it's a bit weak. Yeah, it's definitely a bit weak. So this is 2 phases. You can see 120 degrees apart. Not sure what this bump is. I'm going to do a bit of research and find out. Some sort of back EMF, maybe some sort of artifact from the fact that it's star configuration maybe. Any clever people out there can tell me what's going on with this. I'd appreciate that. I don't like not knowing. Anyway, let's look at the ignition pickup. Right, so I've got one of the channels of the scope in the 2 wires from the ignition pickup. So grey and red and white on this. Let's see what we get on the scope. Right, starty uppy. Wow, okay, right, some adjustment is needed. I'm going to need to turn off that channel, and then we're going to need to keep this waveform still. This isn't a video about how to use oscilloscopes, but see how that we got this waveform and then there's this gap moving along. Well, remember the gear on the crankshaft? That's that gap, but it's not still on the screen. So what we need to do is we need to set a trigger. He says, what am I doing here? Let's change the scale slightly to make it bigger, and let's do that, and then let's set a trigger. So that little cursor there moving is a trigger. So what I've done is I've come up above the amplitude of the normal signal, and on a, see this little thing here, on a downward slope at that voltage it's gonna write the screen. So if I change to, not even sure if you can hear me, I change it the other way, see how now that's on an upward. Anyway, that's not what this video's about. So we can, if what can I do now? So if let me just pause that and turn the bike off so you can hear me. So now we can, with this scope, so it's basically recorded, so we can look through the waveform. Look, you see here, this is basically the buffer. I don't even know why I'm telling you this. Some of you might find it interesting. This is quite good if you're sort of in the wild and you've got a problem. I don't know, maybe a secondary ignition waveform or something like that, and it's quite complicated to look at and you sort of need to ponder it a bit. What I often do is I'll take a snapshot like this, or record a sort of timeline, and I'll go and sit in the van and have a cup of tea and look at it and scratch my head for a little while. So it's quite a powerful thing, this. So what we can also do is we can if we go to here, we can zoom out a bit and we can see the repetition. So that would be 1 rotation of the crankshaft. And if we could be bothered to count all these sine waves, they would be identical to the number of those little square raised pieces on the flywheel. And this is how the ECU knows where top dead center is. So it knows by design, it's built into it. You understand what I'm saying, I'm sure. It knows that where the crank is at this point, and then it's got reference points for every. We could work it out actually if you counted the number of waveforms. There's 360 degrees in a rotation. Each one of these would represent, I don't know, 20 degrees or something. Anyway, I'm waffling, which was kind of the point of this video. Hope you found it interesting, and I will see you on the next one. Cheers, guys. Check this out. How cool is that? So that's those 2 same phases, but with the regulator rectifier connected. And without getting too deep into this, we can see some rectification and we can see some voltage regulation going on. Top of the waveform is being clipped off, and it's, anyway, don't want to get into that now, but how cool is that? I want that as a screensaver or something.